section, you'll learn what elastic load balancing is. Elastic load balancing automatically distributes incoming application traffic across multiple Amazon EC2 instances. It enables you to achieve increased levels of fault tolerance for your applications by seamlessly providing the required amount of load balancing capacity needed to distribute the application traffic. You can distribute incoming traffic across your EC2 instances in a single availability zone or multiple availability zones. Elastic load balancing automatically scales its request handling capacity in response to incoming traffic. Elastic load balancing can also detect the health of your Amazon EC2 instances. When it detects an unhealthy instance, it will spread the load across the remaining instances and no longer route traffic to the unhealthy instance. When you're using VPC, you can create and manage security groups associated with elastic load balancing to provide additional networking and security options. You can also create a load balancer without a public IP address, so it serves as an internal, i.e. non-internet facing, load balancer. Elastic load balancing also supports the ability to stick user sessions to specific EC2 instances using cookies. And if you remember from lesson 2 when we talked about session affinity, this is a version of that. In this demonstration, we're going to create a load balancer for our Simplilearn web servers. So to do that, we'll go to the Compute EC2 section. And I want to show you that before we can configure load balancing, there's a couple of things we need to do. So if we go to Load Balancers on the left-hand side, and then click on Create Load Balancer. So we want to create the load balancer inside Simplilearn VPC. Now I want to show you this warning that comes up. It says please select at least 2 subnets in different availability zones to provide high availability for your load balancer. And you could think, well, that's great, we have 2 subnets. We have a public subnet and a private subnet, and they're both in different availability zones. So if we add them both, we get another warning. It says this is an internet-facing elastic load balancer, but there is no internet gateway attached to the subnet you have just selected. So obviously our private subnet, only has a NAT gateway to provide its internet access, so it's not a public internet-facing subnet. So what that means is we need to create a new public subnet in a different availability zone for our load balancer. So we already have this one, public, in US East 1B. We're going to create a public subnet in US East 1C as well. So to do that, let's go back to the networking VPC section. And this is going to be a quick review of the VPC lesson. So we'll go to subnets. We'll sort by VPC. So here are our 2 existing subnets. So we'll create a new subnet, and we're going to call it, let me just paste what I copied, we're going to call it 10.0.3.0 US East 1C Simplilearn Pub, and we're going to put it in our Simplilearn VPC, and we want to put it in the US East 1C availability zone, so it's different to our existing public subnet, and we're going to put it in that CIDR block. So let's click Create. So there we are. Now we have 3 subnets in our Simplilearn VPC. 2 of them are public. Now, if you remember, when you create a new subnet, it will get attached to your default route table by default. So that's no good because our default route table doesn't have internet access. So we need to go to Route Tables. We click on our main default route table and have a look at subnet associations. We can see that our new subnet is in here, so we need to move it into our custom route table, so it will be the same as our existing public subnet. So if we click on Edit, we just tick the box next to our new public subnet and click Save. So now our new public subnet is in this route table, so it has internet access. So now we're good to go. So let's go back to the EC2 section, and we want to launch a new web server into this new public subnet. So we'll go to But we'll launch it from our AMI because we've already configured our web servers as an AMI. So we'll click Launch. We'll choose T2 Nano. We'll configure our instance details. So we're going to place it in the Simplilearn VPC. We're going to place it in our new public subnet in the US East 1C availability zone. We're going to enable a public IP. We're going to give it the administrator IAM role, and we're going to protect against accidental termination. The storage is fine. We're going to tag this one as Simplilearn Web Server 3. We'll configure the security group, so we'll put it in an existing group, which will be the web servers group, and we'll launch it using our existing Simplilearn key pair, which I have possession of. Okay, so that's launching. So we can see our Simplilearn web servers. So there we are, we've got 3 of them. We've got 1, 2 which are already up and running, and number 3 which is coming online. So now we're ready to create our load balancing. So let's go to load balancers again and create load balancer. We want to put it in our VPC and we'll give it a name. So this is the kind of internal name. We can tag it differently later on because you can't put any underscores or hyphens in this section. So we'll call it Simplilearn LB, Simplilearn VPC. If we wanted to create an internal load balancer, so it was balancing traffic that was just internal to our AWS VPC, we could tick this box. Here's the listener configuration. So what we can do here is we're saying that any HTTP traffic that comes in on port 80 to the load balancer is being pushed to port HTTP 80 on our instances. So what we could do is you could change this. You could have a different port for the load balancer and it maps it to your web servers. So you could protect your web servers, but we're just going to leave it as it is. Now we want to add the subnets, so we're going to add both of our public subnets, and that warning's now gone, so now we're good. We have 2 subnets in 2 availability zones. Next we assign security groups. So we could just use our existing web server security group because that has HTTP port 80 open. It also has HTTPS open and SSH. So it's probably good practice to create a new security group just for our load balancer. So we'll call it Simplilearn Load Balancer SG. And we're simply going to have HTTP port 80 open from anywhere and nothing else. We should probably just give it a quick description so we know what it is. Security group for load balancing. Okay, so let's click Next, Configure Security Settings. And it's just telling us that our load balance security isn't using a secure listener because we're not using HTTPS or SSL, which is fine for this demonstration. Next, we configure the health check. So this is the check that the load balancer is going to perform to see if our instances are healthy. So it's using HTTP port 80 and it's going to look for existence of a file. So we're going to tell it to look for our healthcheck.html file. And if that doesn't exist, then the instance isn't healthy. Now we can configure some more details. So the response timeout is 5 seconds. We'll leave that. The interval between checks, the default value is 30. So let's bring that down because we want things to happen quicker. So that's 10 seconds. Unhealthy threshold is set to 2. So if it has 2 checks where it doesn't find the file, it's going to determine that the instance is unhealthy. And the healthy threshold is 10. We're also going to bring that down. We'll bring that down to 3. So after 3 consecutive healthy checks, it will say the instance is healthy. Okay, so now we can add our EC2 instances. So we'll add our 3 web servers. We've enabled cross-zone load balancing, so it can push traffic across both availability zones. And the connection draining setting we'll just leave as default. That's when it detects an unhealthy instance, that's how long before it will start redirecting traffic elsewhere. So next we'll click on Add Tags, so we can give this a more meaningful name. Simplilearn _load balancer, and review and create. Okay, so we can review everything we did. We should be okay, so let's click create, and our load balancer is now being created. So let's have a look. So here it is. we click on instances, you can see the instances, and it's saying they're all out of service at the moment. So that's because it's just configuring itself, and it will take a while to come up. So I'm going to pause the demonstration and we'll come back when everything's up and running. Okay, so the load balancer has configured, and you can see that 2 of our 3 web servers are in service, but our 3rd web server is out of service. So why do you think this is? Well, I'll tell you why. It's because our new web server, Simplilearn Web Server 3, has just come up and we haven't done anything to it other than just launch the AMI. So let's go and check out what's going on the instance. So I've opened sessions to our 3 web servers here, and this is the new one, and it's because the Apache service isn't started by default. So we need to start the Apache service. Okay, so we get that weird error, but it tells me it's okay. So if we now go back to the load balancer and we wait a few seconds, we should see the Simplilearn web server number 3 come online. There you are, so now we're online. So it was as simple as just starting the service. So that shows how load balancing works. Now, if something was out of service, we could remove it from the load balancer, or we could go and investigate the problem. Or we could use auto scaling to manage it automatically on our behalf, and that's what we're going to look at in the next demonstration.
Hey, want to become an expert in cloud computing? Then subscribe to Simplilearn's channel and click here to watch more such videos. To nerd up and get certified in cloud computing, click here.